Welcome to lecture 1 of module 4. This session will introduce you to the sequential circuit. At the end of this session, you'll be able to compare combinational circuits and sequential circuits. You'll be able to classify sequential circuits, and you will be able to explain the difference between a latch and a flip-flop. The figure shows a block diagram of a sequential circuit. The memory elements are connected to the combinational circuit as a feedback. The output is sent back to the combinational circuit. Now, this is called the feedback. The information stored in the memory element at any given time defines the present state of the sequential circuit. The present state, the external input, and the clock determine the output and the next state of the memory element or the sequential circuit. Now, you have already learned about the combinational circuits in module 3. Now we'll try to compare combinational circuits and sequential circuits. Now one important point of comparison is that the output variables at any instant of time are dependent only on the present input variables in the case of combinational circuits. Whereas in the case of sequential circuits, it is also dependent upon the present state of the circuit. Now the next point of comparison is regarding the memory unit itself. For a combinational circuit, a memory unit is not required, whereas in the case of a sequential circuit, memory unit is required. Now, from the point of view of time of response of the circuit, combinational circuit has a fast response as compared to the sequential circuit, and combinational circuits is easy to design as compared to sequential circuit. Sequential circuits can be classified into two. One is called the synchronous sequential circuit and the other one is called the asynchronous sequential circuit. Now the only difference between these two is that the synchronous sequential circuit is controlled by a clock signal, whereas you don't require a clock signal to control the asynchronous sequential circuit. Now the most important memory element is called the flip-flop, which is made up of an assembly of logic gates. Even though a logic gate by itself has no storage capability, several logic gates can be connected together in ways that permit information to be stored. There are several different gate arrangements that are used to construct flip-flops in a wide variety of ways, and we shall see them later. A flip-flop is also known as a multi-vibrator because it has got two stable states. Now the figure shows the general type of symbol used for a flip-flop. The flip-flop has two outputs labeled Q and Q bar, where one is the complement of the other. Now the state of the flip-flop always refers to the state of the normal output Q. So this is also referred to as the state. Now the flip-flop can have one or more inputs as indicated in the figure. The inputs are also called as excitation. Now the term latch is used for certain flip-flops. It refers to non-clock flip-flops because these flip-flops latch on to a 1 or a 0 immediately upon receiving the input pulse, whereas in the case of a flip-flop, you will need a clock signal for the inputs to get affected at the output. To summarize, we have seen the comparison of combinational and sequential circuit. We have classified the sequential circuits based on the presence of clock signals and the absence of clock signals in the logic circuit, and we have seen the basic difference between latches and flip-flops and what they are.